The next session is code organization. How do you organize your code and why do you do that? So code organization has two purposes. One of the purposes of code organization is to make it easier for the developer to know where to find what and to keep things separate. The other one is to basically have different scopes. So one thing that is quite different in Kotlin from Java up to version 9. Version 9 does this a little bit, but then in a somewhat hard to use way, is that modules are really part of the language. So in Java 9, modules are kind of, you can define modules and then you can say, okay, these are the packages in the module that are visible and everything else becomes invisible and only internal. But in Kotlin, that works at a much more refined language. Kotlin has modules really as part of the language, and you can have a internal visibility. So an internal visibility for an object means that it is only visible by code inside the same module. So Kotlin basically realizes that if you want to stay sane when managing a project, you use a build system such as Gradle. There's others, Maven, and they understand the notion of a module or a library. And the visibility of internal means that we only stay inside. And Kotlin allows you through that to basically express this restriction. And why do we want that? Why is this really important to be able to do this? And why do we need this visibility? So this comes to the problem when we are writing libraries. What we end up with is that that you want to be able to change your library in the future, but at the same time you have other people that are using your library and do not want to change their code when they update your library. So there's two forms of compatibility there. There's the binary interface compatibility, which means that it's compatible even if you do not recompile your code. And there is programming interface compatibility, so that is source code compatibility. That means that you do not need to change your program but need to recompile it. So for example, if you went from a free factory function to a companion factory function, that would not change your source code compatibility, but it would change your binary compatibility, because the function is actually defined on the companion or on the file class. Those are different classes, and that is recorded in the class file that uses this. This is the function or that's the function. They are different functions. That Kotlin doesn't require your source code to know this class to be able to find it is a great feature of the Kotlin compiler, but that doesn't mean that it is not that is the case for the JVM. So that would break binary compatibility. There are ways you can then forward stuff and deprecate stuff. There are ways you can kind of make this work somewhat, but that is what you do with binary compatibility. But there's a lot of things also that break programming compatibility, source code compatibility. So if you add a function to an interface that's not defaulted, that basically means that everyone that implements the interface now needs to upgrade their code. This is an interesting case because this is only an API incompatibility. It is not a binary incompatibility. If you have a class in Java that does not implement all the methods of the interfaces, it will work fine as long as you do not call that function. As soon as you call that function, then the JVM will say, yeah, but there's no implementation here, crash or throw an exception. But if you do not implement the function and you do not call it, it will be fine. Of course, when you implement the source, You do not want to, you have to meet the expectations. So if you have a default implementation, that works correctly. If it's a JVM defaulted one, because the JVM has to implement that. So if you know that your code is never going to be used with Java below 1.6, by the way, for Android you need 1.6, but if you don't have Android and you know it's not going to be used below 1.8, use JVM default everywhere. Use the JVM interface default method implementation, because that makes it work better in this particular context. If you have a function that's public, or you change the signature, so public or protected actually. So protected is public for API purposes. It's just only limited to inheritors. But as long as someone can inherit, so if it is possible for external code to inherit your interface, your class or your interface, or an interface doesn't have protected visibility. But if it's possible to inherit your class from outside your module, then that becomes part of your public API, that method. So if you remove this, anything that uses that function will crash, either binary or in the programming level. If you have a function or a class and you make it final, that means that anything that overrode that function or overrode the class or inherited the class would now be invalid. That breaks code. Of course, if you have a closed function or a closed class that's final, basically, that cannot be changed, if you then allow that to be inherited, that normally works correctly. Again, there are possibly exceptional cases where it wouldn't. Or if you have a class that implements an interface and you no longer implement the interface, that breaks compatibility. Or even then, this is a nasty one, if you have a public constant, if you have a static final primitive in Java or in JVM, what the compiler does, it will actually copy the value and put it in the place where you use that value. And so if you change the value of such a constant, this may be an API breaking change. That depends a little bit on what the meaning of a variable is. If the constant says this is the version that I was compiled with, then you can use it actually as a way to say, oh, you were compiled against an old version of the API, I'm giving you old version compatibility. However, if you are using it for something else, then that can become a problem. Of course, if it's not public, if it's invisible out for code outside your module, it doesn't matter, because a module is always compiled together. So that's this compatibility thing, and that's why we want to have modules. Because we want to be able to limit the visibility, because everything that's not public does not break compatibility. And anything that you make public, you can expect users to use it, even if you say this is actually only for internal use. We find it often that many Java libraries have the internal package, and they actually have public members in such an internal package. Why? Because there are particular things you need to have access to that, but it's kind of used as a warning flag. If you go into an internal package, you may have to update your code if you go to a new version, because it's internal. It's there because sometimes there are some things we know people need to do, but we don't know what is a good public interface to allow this to happen. So we give you a little bit of a hand inside. Of course, another thing you can do is using Java reflection, and you can get at stuff very much. That's just something that is unsafe. The way you do that is using a class called unsafe. Hint, hint. So just don't do that. Next, nested functions. So you can actually use nested functions in Kotlin. So in Java you cannot nest functions. JVM has some support for that, but it's broken. Even Kotlin doesn't use that support in the implementation of nested functions. But nested functions are actually quite useful. So what you do with a nested function is you can put the function inside the body of another function. That's all. It's not really hard, but why do you want to do this? The idea of having a nested function would be that sometimes you have functions that, say, delegate a lot of their functionality to another function, helper function, or if we have a recursive function, we use that. And basically what happens here is that so if you nest this becomes only visible inside that function. So the helper function becomes invisible. It becomes not possible to call this this function without going to the right place, so to speak. And a nested function can also access actually the variables in the outer context. That's quite useful in many cases. And it also allows you to sort your code. So that means that a nested function is even invisible from inside the same class. It's more private than private. So it also makes easy to organize your code. The key part of code is how is it organized? How does it work? That's why we have formatting rules, style rules. That's why we have naming conventions. That it's just easy to think about what happens. Because you don't want to think about those things. You want to think about the stuff that matters. Not, is this visible? Okay, what happens if I change it? Is there something that's going to break? If it is not visible to anyone else, it will not be able to break. You won't be able to break anything else if you update it. Packages. So what do packages do in Kotlin? So in Java you can have actually package level visibility. Kotlin doesn't have this, and many people argue Kotlin should have it. I don't know. There is one feature using annotations now available that actually was designed for having experimental APIs, but it's now used much broader and has been renamed. That allows you to basically put an annotation, and the compiler tells you can only use this if you say I'm using this version or this API, or I'm part of the API. If you have the annotation there, or you have used this annotation, and that kind of allows you to define your API into different slices. One of the things they use it to say, okay, this is experimental. These functions, you can use them, but you need to opt in because you need to be aware that they will change. They might very well change in the future because we don't yet know exactly what the right API is, but we make it available so people can experiment and give us feedback so we know better in the future what the right way of doing it is. So packages do a number of things, even in Kotlin. They provide a grouping for names, for class names, for function names, or for variable names, for field names, for constant names. And within the same package, names are always available with that name. You can, of course, have also the import statements that you can use things from other packages. But you have to import those. Within the same package, you do not. They also allow you to have multiple things with the same names in a different package happily coexist. Because at the JVM level, these package local names are translated in the full name, including the package name, but not in your source code. So if you rename a package, that's yet another API incompatibility. And API incompatibility as well. They also allow you to make programming life a little bit easier, to make sure that you can organize code that belongs together. So it's partially also to like convey roles. So we have an internal package. That means that this package is not really intended for public use. So if you use it, be very, very careful. But there are some reasons, or sometimes there are related packages that you want to provide some visibility for. You can actually do that with the modern Java module system. But if you don't use that, which we wouldn't do in Android, then the only thing you have is the convention. But the convention has meaning. So that is why we would want packages.